So good morning to you all, wherever you are. I'm actually talking to you from Spain, Madrid. Sunny, beautiful day here, to be in the lockdown as well. And we'll be talking about API security, which is the core of what I do as the Field CTO for 42Crunch, which is an API security company, which I co-founded about 3 years ago now. So the goal of this presentation is really to take you through what are the key issues around APIs from a security standpoint right now, and give you some real example of breaches and you know how to why those breaches happened, what did those companies do wrong in a sense, or forgot to look at, or simply let slip through, and make sure that it doesn't happen to you, giving you the proper remediation and approach to actually avoid this kind of problems, right? So before we get into breaches and understanding what happened to those companies, first let's start with how do we secure API? What does that mean to secure an API, right? And really, security for APIs or anything else is really a layered approach. You have multiple layers of things that you have to secure. In the case of APIs, you know, even if you're like entirely virtualized and everything is in the cloud and everything, somewhere in a data center, there's still a machine, a physical thing. And that physical thing needs to also be secured at the operating system level, at the network level, also from, of course, from physical access to those machines. That's all very well managed and everything. And that's not what we're going to talk about today, right? Now, on top of those machines, you have virtualization, because you don't get access directly now to the entire server itself. You have some kind of virtualization layer on top, some kind of hypervisor, it can be Docker. On top of Docker, it could be Kubernetes. You know, there's a lot of different, you know, virtualization systems. And again, at that level, you will have to apply security measures as well, just to make sure the hypervisor itself doesn't get compromised, right? So that's another layer of security you'll have to put there. On top of that, you have communication. What's called communication is really about, so let's say you have an application that have a lot of different services and components to it, right? So in that layer, this is where you're going to secure the communication between those different components. So does, let's take a microservices example, right? Because this is where we have small components that have to talk to each other. You will have a microservices A and microservices B, C, D, E, many of them. You know, how those services will talk to each other. Who can talk to who, right? If I have a backend microservice that's dealing with data, most likely I don't want any microservice dealing with UI and front end to be able to communicate straight into that one. It will have to go through another layer, which is more like a processing layer, just to make sure I cannot, through an API, for example, go straight into my corporate database, right? So all of this is at the communication level. This is where you're going to find solutions like service meshes, for example. Like a service mesh, the role of such a component is to manage easily for you all this intra-services communication and manage whether those encryptions, those communications are encrypted through TLS, how does the authentication between those different components happens, and how the authorization happens. So that's a communication layer. Now, and this is a place where you'll have a lot to work to do in terms of making sure, you know, you cannot navigate within your application the way you want. It has to be controlled, right? But there's still another layer on top of that. That's the one we're going to focus on today, which is now the app itself, right? So the code of that app, the libs that you use, the data that you access. So this is all about the microservice itself, if you want, or the API itself, or the service itself. How do we apply security at that level, right? And really at that level, what we want to manage, what is application level security, right? So it's all about validating that the data, the payloads, the information that flows through my API is really what I'm expecting. Is it the data that I'm receiving? Is it really in the format I'm expecting? Does it have any things I'm not expecting in terms of data, in terms of extra data, of missing data, of the format of the data? So that's all about inbound. Usually that's the first thing we kind of worry about, is making sure somebody is not sending us some bad data that will trigger some bad behavior of our API, right? But also the other way around. How do we ensure that we don't leak some data? And we will see some good examples of that in the breaches I'm going to talk about, right? Or making sure that we don't leak some exceptions. So leaking exception is always a bad thing, because it's something that reveals a lot about what's happening and the implementation of your API, which really should be a total black box and should not be something that external consumers or hackers should be able to know about. So how do we ensure this is not happening? How do we make sure that the token that we use to access our API are actually the ones that we also expect, that nobody has stolen a token and is replaying it, forged a token and is using it. So before we allow to even use that access token for authorization or authentication to the service itself and access to the data, we have to first validate that it's actually the one we're expecting. And finally, at the data level, right? How do we authorize access to the data? So at the communication level I was talking about before, there is some authentication authorization happening, but it's really about whether service A can talk to service B. It doesn't know anything about what service A is doing or what service B is doing, and which data those two services are actually manipulating. At application level, we do know, right? So we know that users have the IDs 1, 2, 3, 4, 5, 6, right? So how do we make sure that, as Isabelle, I actually have access to a resource with this ID? So we're really here at data level, and that's only known at the application level, right? So this is what we're going to focus on today. Now, how does this fit in the Azure story and what we do as well, right? So typically, to do this kind of application level security, you have two main pillars of it, right? You have API access control. This is typically what something like Azure API management would do. This is the place where you're going to govern how you access your APIs, issuing tokens, doing this authentication level at data, right? The authorization, manage identities. All of this is happening inside such a product. Where we focus more is on the threat protection, right? Which is another pillar of that. Typically, this is the type of work that a firewall is doing. So in our world, we have something we call an API firewall. But basically, the role of a firewall, the same way you have a network firewall to ensure that packets are the ones you're expecting and you can open certain ports, etc. You have the same thing at the application level, where we can look at the content and understand that content, look at those tokens I was talking about, manage the traffic, maybe look at the payloads themselves, so the requests and the responses, and be able to sign and encrypt them for additional security. And this is where we're going to detect those threats. I use all this information of all the requests coming in and out to actually detect some patterns and block somebody who's trying to maybe abuse our logging operation on our API, for example, right? So that's kind of the overall picture of application security. Now, for security, we need principles. We need some guiding principles, right? And the first guiding principle of security in general, and API security, application level security in particular, is a zero trust architecture. What does that mean? It's kind of an overused word, and a lot of people are talking about this, but from a principle point of view, it means we don't trust any information coming our way, any request coming our way by principle. So it doesn't matter if I discuss it with customers all the time and say, well, if I'm in a microservice architecture and I'm developing a microservice and my buddy Joe next to me is developing another microservice, right? I'm going to trust that one, of course, because it's written by my buddy Joe and I know him, and he's not going to try to abuse my microservice, right? So maybe we trust Joe, right? But what about another microservice that maybe we're consuming from somewhere else, or that's not been written by us or anybody in the company, or who knows, right? So if you start putting some exceptions, saying, well, now we're going to trust it because A, B, and C, then you're going to try applying different rules and to things that are going to trigger. It's very easy then to have conditions and exceptions that are going to become the entry point for problems, right? So it's much easier to just say, by principle, there is no trust, right? We don't trust any of the data. It doesn't matter who is actually invoking us. By default, we don't trust that that call is made by somebody we trust, right? So it means we always verify the contents, we always verify the authorization, the authentication. There's always SSL, etc., etc. And it's all the same, right? So apply the same principle and the same security principles across the board. Then what I mean by all APIs are open APIs. What really that means is, again, let's not make a difference between, oh, but my APIs, they're just consumed internally. And that's okay, right? Because we're internally, we trust everybody within the company. So nobody is going to abuse those APIs, right? As opposed to, oh, this is an open API that I'm exposing to the internet or even to partners. So it's not only an internal consumption. So in that case, people understand more and say, oh, yeah, of course, there is more risk there because I'm opening it to the outside. And again, let's apply the same rules to everything, right? Should you have internal APIs, external APIs, partner APIs? Let's secure them and follow the same principles of security across all of them. Let's not make exceptions, because if you start again, same principle as before, making exceptions, then you're going to open problems, and this is where you're going to open the door to problems on certain APIs and not others, etc. Now, this is to that principle number 2, we have to add something else, which is risk, right? So of course, I'm not saying that you should just consider all your APIs exactly the same from a security standpoint and apply the highest security standards. That's okay if you want to do that, but really what you should do, there's a cost to high security standards. It's the same thing as putting, if you have a door to your house and you put 10 locks on it, right? There is a cost to that, which is going to take you 10 minutes to open your door. Yeah, it's very secure, but it's you have a lot of, or if you put some fingerprint system to read your fingerprint before you can get into your personal house. Do you want to do that to enter your personal house? Maybe not. Do you want to do that in the data center where all my systems are in Azure cloud? Yeah, probably, and more than that, right? So the security principle is still that there is a door to enter everywhere. Now, the way to open that door is actually different depending on the risk, right? So you need to do the same thing for your APIs, depending on the risk. So if you're a banking user, right, and you're manipulating sensitive data, or you're passing money from one account to another, then that risk of this API being abused is obviously higher than if you're the weather channel, right? And you're manipulating weather data, which is we can say insensitive, in the sense that if somebody steals it, well, you've stolen the weather data, okay? And usually, fortunately, this is only in read-only mode. We cannot change the weather yet, and hopefully we'll never be able to do so. So it's it's not the same risk, because the data you're manipulating has less sensitivity. The operations that you're doing have less sensitivity. So you need to know your APIs. I guess this is the key message here. You have to know your APIs. You have to know what they're doing. You have to know the data that they're manipulating. And based on that, you're going to adapt the security on top of them based on that risk, okay? Now, those principles, they're going to help us protect APIs that have really evolved, the applications, have evolved a lot in the past 10, 15 years, right? We went from a security architecture, which is very much like this this picture you see now, where in ancient times when we're building a city, there was the core of the city, which you see on the picture, and there will be walls and walls of protection, right? And 3, 4 walls plus the door plus water and boiling oil and whatever it was when this was under attack, just to make sure that if the first protection was falling, there was still another level and another level, right? And it was perimeter protection, right? So you would protect, you would put this wall around yourselves and protect the perimeter. Now the perimeter is pretty much gone, right? So rather than having, you know, this wall with one very single door, which is very well-known door, and that's the only way to get in, you have those multiple walls you have to pass to get into the inside. Now we have this one thing in the middle, which is still the heart of our system. And we have dozens of avenues coming into it. And every time you open an API, you open a new avenue. It's like you open a new road to get into the Arc de Triomphe here in Paris, right? So it's not about, which means that the focus now has really changed. The focus of security is not about securing the perimeter. It's about securing the data. It's all about accessing the data and securing the access to that data, right? So you cannot just build more walls because you're punching holes all over the place through that wall anyway. To talk to external APIs, to create your own APIs. So, you know, the principles have changed very much, right? So, what also is specific about an API-based application is there are some specific threats attached to them, right? So not only has the perimeter changed, and the way we do security is changing, the way we do applications is changing. And all of this is kind of moving at the same time. And, you know, within the next probably 5 to 10 years, every single application that we know today will have a backend which is based on API. It's still not true totally right now because we have a lot of history and things we cannot change, right? But all the new applications certainly are built this way, right? And when you create an application with APIs, basically what you're doing is you're exposing, again, you're punching all those holes in this perimeter, right? And you open all those avenues for people to come in. So this is becoming now, and it has really started to pick up in the last 18 months. And as you know, Gartner is saying, it's going to continue and increase over the next 2-3 years. This is becoming the #1, you know, attack vector in the enterprise now, for small and large companies alike. So as 42Crunch, we're curating this website called APIsecurity.io, which really is a community effort to educate people about APIs and about API threats, report problems, so that you can learn from others' mistakes, what we're going to do in a second, and not repeat those mistakes yourselves. But if we look across, you know, those 200+ breaches that we have reported in the past year and a half, pretty much, you know, the same problems come back again and again. Lack of input validation. This is back to my story about trust, right? It's like we trust that the data that comes in is actually valid, so we don't validate it, right? And therefore, that's how, you know, we accept information we actually should not accept. And this has been going on for like 20-30 years, since the beginning of applications, I guess, and it's through the applications that we tend to, you know, it's very easy not to validate what we receive. Bad security configuration, I'll give some examples of that as we go along. Broken authentication, broken authorization. So those are the main issues, and we'll talk about some specifics right now. Now, about 9 months ago now, the OWASP has recognized that, you know, APIs-based application is not the same as others through the release of an OWASP top 10 for APIs. So I'm sure you all know about the OWASP top 10 for applications, so, which has been there for a very long time. And doing this specific list for APIs, what the OWASP is recognizing is there are a number of threats which are specific to the fact that we architecture our applications in like, let's say, a fat JavaScript type client and APIs in the backend, because we again give straight access to data and processes through those APIs. So we'll go and talk about some of these as we talk about the breaches specifically, okay? Which is where we're getting now. So real stories and lessons learned. So this is really about real things that have happened, what and how they relate to the OWASP top 10. So the first one I wanted to talk to you about is something that happened about 2 years ago, almost 3 years ago now, time is flying, to T-Mobile, but it's really like a book example. So one thing, as you see on the right here, I have A1 to A10, and some of them are in red. This is to show you the combination of problems that have happened here that made that breach possible, right? And this is also a very key lesson. In most of the breaches I'm going to talk about, or the problems that I've been reported, you will see it's very rare that a massive breach happens just because of one problem in the 10. It's usually a mix of 2, 3, 4 problems. So that one vulnerability is used to obtain some information, and another vulnerability is used to exploit the information that we have found. So in the case of T-Mobile, and on each of those, you have this vice.com for the article here below. You will have the presentation later, so you can go and read more about this. But basically, at the root of the issue here is I'm a user. I can connect to an API from T-Mobile, and I have a token. So I have a valid token that I have obtained in a legal way, which allows me as Isabelle to go and invoke this API and get the full profile attached to my phone number, okay? Now, the problem is I can also put the phone number of Lisa and I'll get her profile, right? And why is this happening is as one of the top problem called, you may have heard something called IDOR. In the OWASP API top 10, they call it BOLA. So it's this broken level authorization. Basically, the idea is the source of the issue here is twofold, right? The first one is because, of course, this is a phone number. The ID of the user is a very well-known format. So it's very easy to generate phone numbers automatically, which is exactly what the hackers have been doing. They've been just exploiting this by getting a token and then having something that would just generate phone numbers automatically and see if the API would be answering some profiles. And that way they have retrieved millions basically of profiles of numbers, right? So the source is one, I have a user ID, an ID, which is guessable. So I can iterate on this. So if you have an API that uses an ID called 1234, then I can try 1235 and see if that works, right? So that's one thing. And the second thing, of course, is an authorization problem, which is that as Isabelle, I should never be allowed to see Lisa's phone number's details and vice versa. So somewhere down the line, there's some logic missing to validate that I have the credentials to actually access that specific resource, right? But on top of that, two other things happen here. This API has been abused for months. There was even a movie on YouTube explaining how to abuse this API, which means they haven't seen anything for months, right? And really this happened for two reasons. The first one is there was no really rate limiting on this API. So they were able to just do, the same way you can do credential stuffing. So try user ID and passwords found on the dark internet and try to, use them to logging into a system. If you want to be successful as doing that, the logging API really basically needs to have no rate limiting so that you can do millions of calls on that logging until they actually work. and see which ones work. Well, it's the same thing here. They've been able to get millions of calls going unnoticed. One, because there was no rate limiting, and B, because their logging infrastructure and alerting infrastructure obviously didn't work well here. Because somewhere on a dashboard in the data center, there should have been a big red thing blinking saying, there's something really wrong going on there with this API, right? So how do we protect ourselves from this, really? So first of all, it's all about authorization, right? So fine-grained authorization. I should not be allowed to, as a user, as a system, calling an API, to be able to consume data and access to data I have no business with, right? So you really want to ensure from an authorization point of view that you don't actually allow that, right? And the other one is really to have a clear separation between internal IDs and what you expose through the API. So within, you probably all have data in a database somewhere, which is using some user IDs, some unique IDs, which are yours. That's okay. So those should just stay inside your company, right? And don't expose outside those internal IDs. So you have to have a mapping somewhere between the data that's internal and the data that is actually exposed through the API. And the other thing is you can do is basically do not use the ID that the user is giving you when they make the call, but rather have them in session. So when somebody logs into the system, they get a token, probably have a session somewhere, and in that session you associate the data, that they have access to. And basically when the requests come through, you want to validate through that session that, hey, that user is calling me, they're trying to access some data. That's not the data they were, allowed to within that session. So no, I'm not going to do that, right? And finally, avoids those guessable ideas. So usually the solution is to use UIDs instead, so something that cannot be guessed, so that nobody can enumerate through your API what the data is and guess what the IDs can be, right? And finally, don't use IDs at all. So in the case of T-Mobile, one thing they could have done is say T-Mobile phone management, me or mine, right? And then you can say, oh, mine, what is mine? Okay, so I'm going to Isabelle's profile and that's her number. I'm going to Lisa's profile and that's her number, because I know who they are, and so you don't allow people to even use an ID. So that's kind of the combination of things you can do to mitigate such threats. Of course, you also want to put rate limiting in place. We'll talk a bit more about rate limiting in another breach that happened a bit later. Just do smart rate limiting here, that what a single user can do within a specific session, right? And what makes sense for them to retrieve. They have one phone number, probably, chances are I'm not going to retrieve my profile every 2 seconds to see if it has changed, right? This is a call that should happen once every X. So think about how what is the business, the usage pattern of an operation of an API, and put the proper rate limiting and limits based on that, right? And of course, you want to log everything that happens, right? So all those calls that come in, should they work, should they fail, especially if they fail, you want to put that into, some kind of SIEM or logging architecture that can do two things. First of all, you need this data for forensics analysis. So if something happens, you need to be able to go back somewhere and find that information. But more importantly, when it happens, you need to have some thresholds and some alerts popping up somewhere saying, hey, something is really, out of the ordinary here. The patterns of calls that usually we have here are not the ones that we see at that moment. Go and check, so at least a human can have a look at it and decide whether this is normal behavior or not. All right, so that's number one. Number two, Facebook. So this happened about a couple of years ago now, a bit more than that. So this is not a breach because this was a bug bounty. It's something that Facebook paid for to have their API being analyzed. And here, this is the way it works. So when you reset your password, if you're using Facebook or any other, many systems use the same system, you will be resetting your password, and some kind of, token will be sent to your telephone, to your phone, for example, right? So you have this like 4 digits or 6 digits code as being sent to you, and you have like 5 minutes, 10 minutes to actually bring it in to reset the password. Okay, so that's the way it works. Now on the real API, on the real Facebook API, there is rate limiting, when we're talking back to rate limiting before, that will prevent somebody from doing like a brute force type of attack where they don't know the reset code, of course, so they'll try to guess it, right, through brute force. So basically, it's you against the machine. You have put a password reset of, like, say, 5 minutes, which means the hacker has 5 minutes to try as many combinations as possible. And, obviously, with some luck, they're not going to be able to do that. And the 5 minutes will expire and a new token will be generated. And that's the way it should work, right? Now, Facebook has a beta version of that API. And in that beta version, there is no rate limiting, right? So that's the problem, right? And that's a very common issue, which is we tend to protect only production systems, and we forget about the QA and the beta, or the what we consider non-production, right? Except both the beta and the other API point to the same data. So this is not a non-production system versus a production system. It's just a different entry point, right? So the rate limiting was not there. So this is really broken authentication now, right? So now how do we protect ourselves from this, right? First is doing what I call smart rate limiting. By token, by user identity. So you have to be careful about doing rate limiting by IP. It's very easy to forge an IP, and second, it's very easy now for anybody, and that includes hackers, to create tons of little machines on their cloud platform of choice. They can just pull out a credit card, put $100, spin up 1,000 very, very small machines. They all have a different IP, and they can all attack at the same time, right? So if you do this only by IP, you're opening yourself to that problem. And this is exactly what happened to Instagram. So this is an interesting problem as well, which is very related to the Facebook one that you can have a look at as well, where they got and the same problem, and the limits and the rate limiting on their password reset was 200 attempts by minute by IP. So what's the problem with that number? If I'm a human, right, password reset is used by humans. A human, I defy any of you here now listening to this to try to do password reset 200 times in a minute, right? As a human, you're not going to be able to do it. As a machine, that's a different story, right? But that limit really should be for human. So maybe 3 attempts per minute or 5 attempts per minute. That's already quite a lot, right? So and plus by IP. So what happened there is exactly what I said. A hacker just again, this was like I think it was a bug bounty. Just took 1,500 machines on a cloud, give them money. It cost them $130, I think. And then because they had all those machines on different IP, and they had 200 attempts per minute, and the lifetime of the token was 10 minutes, they were able to crack the password reset code very easily using that method, right? So again, you have to think about what is it that you're protecting, and the rate limiting that makes sense for that specific operation, right? And of course, you want to put in place two-factor authentication. Maybe, even if we don't like it very much, put in type some CAPTCHA. I know that many users don't like this, but it's a good protection. Make sure your credentials cannot be stolen, and put them in some secure storage, especially if you do mobile application. Okay. And in general, to counter the fact that somebody can stole a token and reuse it, use tokens which are very short-lived, right? In our platform, the normal time is 5 seconds. Why is that? It's simply because it's very cheap to create access tokens. You can create an access token for every request if you wanted to, right? So if you create an access token on the fly to access an API, just create one, do what it has to do, and that token dies. So even if it's being stolen, you have a problem, that's okay, because they will never be able to use it, right? And also limit the scopes that those tokens have. Don't get users to create one token that gives them access to all the API and all the operations. Get them access tokens that they can generate very easily for a specific operation. So you're not using the same token to get the list of ATMs around my house than to do a payment, right? I know from a development point of view, it's a bit more work, and it's probably a bit more work on the client side as well. But it's really worthwhile in terms of security. Again, depending on the risk attached to the API, right? And finally, just from this point of view of where is the production data and from what is it accessible, right? You always want to separate non-production from production, or you put a subset of production data, you change it, you extract some information because it needs to be real for testing, I understand it, but extract some data, maybe change it, redact part of it, I don't know, but make sure it's not exploitable, basically, if it's compromised. And again, if your APIs, I work with a lot of customers that tell me, oh, you can go and call our staging API to do some testing of your platform. So their staging API is open to the world. The minute it's open to everybody, right? Then it has the same risks as the production one. So if you separate the production data from the non-production one, the risk is lower, but you still have an entry point into your system, the same way your production endpoint is your entry point into the system. So you want to protect it and govern it and manage it the same way you're managing the production system, right? So don't make this separation of, oh, this is production versus non-production. So non-production, we don't have to secure it. And it's like, no, don't do that. Just do it across the board. So then there is no question. Plus, if you have put the protective measures across the board, then when you get into production, you don't have this surprise of, oh, now we have security in place, so the API is not working the same. No, if you do this from dev, then you know, and from a development perspective, you have tested all those security use cases way before you get into putting the API into production. So this is good from a testing and validation perspective as well. Okay. Next one is Uber. So this is pretty recent one. This is just one thing. This is like a massive data leakage problem. So what is data leakage? What's the root of this? In many APIs we see, what's happening is I'm creating an API and I have all this data in my backend, right? So rather than creating maybe multiple APIs with multiple profiles for every way the data is going to be exposed and displayed, we say, okay, well, we'll just take the entire DTO in the backend, all the data, we'll just create this big JSON structure, and then the client side will do its job and will filter out what it doesn't want, okay? So really, this is a major issue. That's the second one in that list here. The other one is this problem of leaking information through exceptions. So what happened here is, again, this is a bug bounty, okay? What happened here is somebody, the white hacker who did this, is put a driver phone number into through the driver API of Uber, okay, and is tried to invoke some operations. And as part of one of the APIs that it has been invoking, this message that you see on the screen came back, which exposed, remember we talked about UIDs 2 problems ago with the T-Mobile thing? So actually Uber here is doing a good job. They're using UIDs, those non-guessable IDs that I was talking about, to identify a driver, and that's all good. The problem is they leak it through that exception. So now I have this UID to invoke other parts of the API, and that UID is valid, okay? So the second part of the problem was through another part of the API, using this UID, the hacker was able to retrieve the entire profile of a user, including the token to authenticate through the mobile Uber app, right? So when a driver apparently, starts their day, they have to authenticate to the app, and they have to enter this token, obtain this token. Well, that token is stored together with their profile. So that got leaked as well. Of course, and once you have the mobile token, then you authenticate to the app using the token, and you're the driver, basically, right? So what's going on here? And I see this a lot in all the people I'm working with. You really, really have to take control of your JSON schemas, right? You have to take control of your data and describe thoroughly, and what I'm meaning by thoroughly, and I just underlined in here, is not only this is a string and this is, and this very loose schemas I see, which are very open, where I can make data nullable, I can add extra properties to schema, so really they don't enforce anything because they're so loose that you can put any type of structure in them, right? So again, I know this is more work. It's actually more work to define this properly and have multiple schemas. So the key thing here is not to say, well, I have one schema and one set of data for everything. No, you probably will have multiple sub-schemas for the type of requests and responses. So you don't have the same schema, for example, to expose data through an API to do a get. So they may give me the profile of driver foo, right? That's one type of data, and that's one structure. Update the data of driver foo is another problem, because probably you cannot update all the same data than the one you return through the API. So those are two different schemas, right? So that's very important. And one thing everybody seems to be forgetting, while we're kind of conscious that we have to look at data that comes in, the requests that comes in, we tend to forget about the data that comes out. And that's exactly what happened here to Uber, is that the first response that comes back contains this UID, and that should not have happened. And second, the other one has like the entire profile with 170 line of JSON. That should not happen by well. So this needs to be a review. This needs to be approved. Just make sure you don't leak also GDPR information or sensitive information. There's all kind of compliance and regulation around this as well, right? That can really bite you here. And of course, you really, as I'm saying here, you really shouldn't be very conscious about the data that you're actually returning in a response. So no sensitive data, no exploitable data beyond what the client actually needs, right? So don't rely on the client apps to filter the data. What you want to do is have different endpoints, different operations that you can call as a consumer to get the data, and more importantly, maybe depending on the consumer, you'll have a different API. So let me give you a concrete example. If I have a banking account, right, or in the health or so, this is a very key thing in the health industry, right? If I have an entire report, a health report on the person, right? Depending on who is going to consume this, is it my internal company because I'm I'm an insurance company or I'm a hospital, right? Or if I'm going to open this to the world, to my patients, for example, so that they can see their own data and maybe, you know, and I'm also sharing that with third parties because I want them to sell them some insurance through it, right? So it's the same data, but consumed by very different people. That cannot be the same API. Those are three different APIs, right? Or like the interface is very different because the schemas and the data you're going to return and how you protect it and everything is going to be very different. So you really want to, again, it's a bit more work, but that way you make sure you control who has access to what and which data is controlled by who, okay? If you have a single endpoint for everything, it's going to make it much more complicated and error prone. All right. And of course, we could not talk about all this without talking about Equifax. I'm sorry for Equifax that I keep talking about them, and this has been happening quite some time ago now, but it's just because it's a very critical error that has happened so many times. And it's happened to them, but actually it happens to hundreds of companies. Of course, they kind of eclipsed the news because of the mass problem here, but a lot of people got caught by this. And basically, what the root of the problem behind Equifax and many others is an patch library from a library from Apache, from Apache Struts, that went that had a vulnerability. That the vulnerability was widely exploited during months. And the fix was easy. It was just to upgrade basically to the next version, right? And many applications didn't do that. And there's two basically problems. The root problem of this is, I don't know if you can see this properly, but those 7 lines here, or 8 lines from content type to accept are the contents of the content type header, right? So if you're developers and you know this, you know within the content type, the only thing I should be able to put is the actual content type. So application JSON, application XML, nothing more. And look at what those guys were able to put in there, like an entire process that allows you to basically become an administrator of the system and start editing the IP tables, etc. Right? So why is this happening? Because obviously back on the on the back end, the validation of the content type is really not happening properly, right? And so what happened here is two things, right? Really, you want to keep your software at the latest level. So this is really a critical part. It's not so much about your code itself, but all those libraries and things that you're actually reusing. So being able to understand what are my external dependencies, are there on par with CVE database? Is there any known vulnerabilities in there? And there are many moving parts around this. So I really encourage you to invest and put in place some automatic system. It can be SNCC, as I'm showing here. It can be, the inbound system from Azure Cloud if you're using containers from the container registry. It can be, GitHub and the automatic security validations. But if you want to keep on top of all the things that you use, and you use a lot, you will have to put some automatic management in place here. So you want to do that for every single library, container images, all these things that you're reusing, which are not yours, right? You have to always look at them and see if this is really the latest level and whether there are any problems attached to them, right? And of course, content validation. So whatever comes in, you want to validate. And something which is, and I've seen that many times, the content type in particular, depending on the libraries that you use, whatever library it is, right? If you put a wrong content type, there's some predefined behaviors that that happen if you're not overriding them. So check that. Do some testing on what happens if I'm sending XML and I'm expecting JSON, or if I'm sending something that has nothing to do with a known MIME type. How is my framework reacting, and what type of things? Sometimes it just, creates its own exception or creates its own response that you don't really have a control over unless you override it. So check that just to make sure what happens if the requests that comes in are actually bad ones. Okay, and for the sake of time, I'm just going to jump on this one and go straight to the conclusion. So as you can see, all those known companies have been, bitten either because they got some breaches or, through bug bounty. Now, how is this happening, right? It's happening mainly because of humans and human error. That's really what happens. And the fact that, as developers, you have to work really hard to deliver functionality, and there's no time for everything, right? And this is where I'm going to advocate very soon for automation. So now you looked at this presentation, either you're like happy under the sun and say, this is fantastic, I've done everything that was in those mitigation page, I'm all covered, I'm happy, this is cool. If you're in that case, that's fantastic. My bet is you're more in that case, which is, wait a minute, we have all this stuff that I need to look at and fix. How do I address this problem? I have like 100 APIs, thousands APIs. Where do I start, right? To start looking at all those problems. So what do you do, right? So first of all, don't panic and pick your battles. What does that mean? I'm back to what I was saying at the beginning. You need to know your APIs. What are your most sensitive APIs? If tomorrow you have a breach in your company, what are the APIs that are going to leak the most critical information that you're going to make it into the news, right? Those are the ones you want to concentrate on, right? So establish like a threat model. What are the risks? What is the data? So there's lots of, if you look for threat modeling on the OWASP, for example, there's lots of frameworks on how to do this, right? So you know what you're going to target first. And if there's one thing, that I can advocate, is that you really, really start worrying about security as early as possible. Many of the problems we've seen, and all the people I'm working with in my company, many of the problems they have is because they tend to look at security very late in the API lifecycle, at a point where it becomes very complicated to be efficient as security teams to get those problems fixed before the API goes into production, right? So keep this number in mind. Whenever you find a problem in production, it's going to cost you between 15 and 30% more to solve than if you find it at design, at development time, right? So try to shift left and introduce automation, and for example, those libraries validation I was talking about. This is something that should be in place in your pipeline. So every time you push some code, automatically there's something that just go and turns and say, hey, you're using library foo at version 1.2.3. It has a problem. You have to move to version 1.2.5, right? So the earlier you discover that, the better, because of course now you can test with 1.2.5, and if there are problems because of the migration, then you can fix them right away, as opposed to, at the end of the life cycle. And then is hacking yourself. So what I mean by that is we tend to really write functional tests like this. When my API, I'm invoking it, and, I'm testing the happy path. The happy path of sending some data and getting some response. Now, what I would like you to do is to test the hacky path. What that means is, for every single functional test that you do, you want to write 10 negative tests. Just send to your API all kind of bad data, bad token, bad user, all kind of crazy formats of all sorts. And that's how you're going to discover really how your API works under security stress. Right, and you want to automate those the same way you automate the functional tests, and just hammer your API with all kind of bad stuff as early as possible in the lifecycle of API. And of course, automation is your friend here. if you're building one API, two APIs, doing this manually, those tests, everything, okay, all that's okay. But most likely, if you're like all the companies I'm talking to, you have 200, 300, 400 APIs. And that's where manual just doesn't work anymore, right? So you want to adopt shift left, DevSecOps, maybe use your, Azure DevOps, Azure pipelines to start injecting security checks as early as possible. And just consider security as early, and consider security as fully part of your API development story. Okay, and that's what I had for all of you today.
Thanks, Isabelle. That was awesome.
That was great.
I really liked the point at the end there about the fact that if you find an issue in production, it's going to, cost you way more in time and effort to fix than if you'd solved it whilst developing. And I think that's a really good way to remind people how important this is, because even as people, still don't quite get it, like security is major, it can happen to anyone. But when you talk about time and effort, everyone listens.
It never seems that important until you get bitten, and then you suddenly realize.
Yeah. Indeed.